artificial intelligence and application, and how we use them at the end in the ALCHIMIA software. I will try to speed up the presentation as possible in order to go as soon as possible to the software solutions in order to show how to use them. So artificial intelligence. We often heard about these two terms, and basically we are using it since at least 15 years in our mobile phones. How? Basically, when the first application we, as users, as normal users, we used about the artificial intelligence was the Gboard, so the keyboard that we are using on, for example, WhatsApp to write messages and so on. And if you pay attention to also to the current, the new versions of these keyboards, they forecast the next word in function of what you typed before, basically. And sorry, some noise in my room. And so basically, in other terms, what is artificial intelligence? Artificial intelligence is basically a branch of the computer science. Let's say a set of equations that try to emulate or to give, let's say, the capability to a machine, to a robot, to an algorithm to think in an autonomous way, let's say in this way. And it's an emulation, so it's not real intelligence, but somehow it emulates it. The idea comes from, let's say, the need to, let's say, speed up certain, maybe sometimes repetitive tasks, no? Where people can be supported by autonomous software in, for example, making some decision or understanding some decisions, for example, or understanding some measurements and so on. And how it works, artificial intelligence? Well, as the human intelligence it tries to emulate, let's say, to learn from by experience. In the case of artificial intelligence, we learn from the data. In our case, the model learned a chemical, or for example, a chemical physical behavior from the data measured in the plant, for example. Makes decision, can make some decision. We will see later what does it mean make decision in the case of artificial intelligence. Can identify some patterns that are common in the data, and as I said before, can perform specific tasks. But remember one thing, artificial intelligence follows some logics and instructions. So in particular, maybe, I don't know if you ever tried the ChatGPT. Sometimes it seems that it has some emotions and feelings, but it's not, let's say. It's only a replica, let's say, a replication of the human behavior or the way of human thinking, let's say. Okay. We use it in several daily applications, starting from Siri, Alexa, Google Assistants that help us in, for example, control the lights of a room, or give us some reminders, or help with, let's say, organize the tasks of the day in the calendars, for example. Recommendation systems like such as, for example, Netflix or Spotify, that are systems based on artificial intelligence methodologies that suggest us some contents, some products, and from, let's say, our previous behavior, let's say, or let's say, typical behavior of a specific human category, let's say. We use it very often as to filter the spam in the emails in an automatic way, and so on. Tesla, for example, the Tesla car is full of artificial intelligence methodology for recognize signals, stop signals, or I don't know, give precedence to the others, or we have a lot of stuff like this in the social media, and also application for doing translation of language. and so on and so forth. How it is born? Probably you saw the movie about Alan Turing. That was the guy that helped let's say, the scientist that helped the military in the UK for, let's say, translating let's say, the cryptographed messages of the Nazis, where they let's say, where the Nazis tried, let's say, to schedule somehow the attacks on the UK boats. And so basically through a sort of, let's say, very rudimentary sort of computing application, he helped the military, the UK military, to the army to, let's say, translate these cryptographed messages. And the idea of Alan Turing was, how can we, let's say, help somehow machines or stuff to think like humans. That was the idea in the 50s. So it's a science basically that started. Well, it became popular in the last 10 years, maybe, but it started, well, 60 years, more than 60, 70 years ago, more or less. How it started? Well, basically, as science becomes popular and becomes more advanced, where when scientists find money. In other terms, artificial intelligence, the first application of artificial intelligence provide, let's say, some proofs that this methodology can be continuously studied and improved and improved and improved, and in these days we are using it continuously in our lifetime. The idea is to try to use it also in industrial for industrial tasks, as in our case. Maybe you heard about machine learning. Machine learning is, let's say, a set of algorithms, a set of models that, let's say, learn from the data. It's a subfield of artificial intelligence where the models, these mathematical models, improve their performance and learn some physical behavior or language behavior and so on from the data that we can collect, with the objective of generalize the input. So the idea is to how to leverage this model to perform tasks that the artificial intelligence based model didn't see in the past during the training. So how to generalize, how to understand, let's say, some behaviors that we like to model. How we trained, few words just to mention the words that you probably will hear very often also in the future. Supervised learning or unsupervised learning. Let's focus on supervised learning. What does it mean? Well, basically, we give to the artificial intelligence model some example in terms of input data and correct answers. You can see it in the screen, in the right side of the screen. We would like that, for example, the artificial intelligence model can recognize let's say, to identify apple and pears. How this algorithm works? Well, we have the input data in terms, for example, shape of the fruit, the color of the fruit, or specific, I don't know, specific characteristic like the leaf of the fruit, like in the case of the apple. And from this input information, input in terms, for example, of images or videos or description, textual description maybe of the fruit, basically the model recognize after a learning phase apple and pears by classifying them by learning from previous data from the correct answers. So we know what was apple, we know what was pear, and so. What kind of task artificial intelligence can perform? Well, several. In general, in industrial application, we are more interested on classification and regression, or also called approximation tasks. Forecasting, for example, forecasting of some phenomena. For example, we would like to forecast in advance if we also have some defects in our production system, for example. If we can forecast it, some defects on the product in advance, we can understand how maybe to improve the control of the process. For example, in our case, by adding some carbon, some silicon, stuff like this, for example, just to make some example. Classification task, what is? Well, few words. Basically, in a classification task, an artificial, or in general, a machine learning methodology try to classify stuff into categories, so groups and categories. So the idea, for example, a goal, for example, is to predict if an email, to understand if an email is spam or not, or I don't know if there will be some kind of defects in the production or not. What is a regression task? Well, the regression task, also called often called as approximation task. It's a task where typically, if you think, let's say, to polynomials, that we use to, let's say, approximate some numbers, some behavior. Well, artificial intelligence works in the same way, basically. Trying to, let's say, identify some parameters of the mathematical model, of the equation of the model, that minimize a certain, for example, certain error, some accuracy, and so on. An example, so in this case, the model helps in predicting some, not categories like in the classification task, but some numbers, some values. For example, a possible application is to estimate, as in our case, the final chemical composition of the steel at the end of the ladle furnace, starting from examples, from example by some input variables that we can measure in advance, like the mass of the steel, what kind of additive material we would like to add, like ferroalloys, first temperature measurement, how much argon use, and so on. Well, I think that these two tasks are pretty understandable. So classification predicts group, regression predicts numbers and values. Let's go directly in the type of artificial intelligence methodology that we use in the ladle furnace. So let's keep decision tree. That is let's say, a kind of artificial intelligence methodology that we use in other applications. Let's focus on neural networks. What is a neural network? Well, a neural network tries to emulate the behavior of the human brain, basically. It's a field of the machine learning, so it's a field of the artificial intelligence. So artificial intelligence is, let's say, the main group. Machine learning is a sub-part of the artificial intelligence, of all the artificial intelligence methodologies, and neural networks is a part of a subgroup of the machine learning. The idea is of the neural networks is, in fact, to emulate the human behavior. And in fact, there are several applications where this kind of methodology works pretty well. How they works? Well, let's see it in an abstract way, with some examples that are more simple, that showing some mathematical equation at the end. So we have some input data, and we would like to calculate some outputs. What are the outputs? Are some answers, some classification, or some values, some forecasts, the weather condition of tomorrow, and so on. How it works? Our network is in the figure in the middle, we see hidden layer. It's the part that is hidden, the part that somehow do the reasoning part. And it works like an operator. For example, an operator that in his lifetime, in his work experience, checked a lot of product types, seeing defects on it, or what are the good shapes, and so on. And so starting from his senses in terms of sight, or for example, in terms of touch. It learns in his with his work experience how to recognize, for example, the defects on a specific product, or and so on. Let's imagine a chain of operators that each focuses on specific aspects of the product. Let's suppose that we have a production chain where some operators and some machine produce some gear for some or some parts of the brakes of the car. The first operator, for example, checks the size of the product. The second operator takes, let's say, the information of the first operator and checks with a focus, let's say, in the shape, so in specific details of the product. And the final operator, let's suppose, focuses on checking if there are some specific defects, for example, cementite in a product, or some cracks in specific metallic parts, or I don't know, problems in the color, I don't know, different issues. And then at the end, this chain of operators during their check takes together a decision. Well, neural networks works in this way. Without going into detail, well, neural networks basically have some equation inside that describe very well, simulate the behavior of the connection between the neurons through the synapses. So how the human brain organize the information that we collect through sight, through tactile, from our skin, or I don't know, from our ears, and so on. All this kind of information. How can we train these models? Very briefly, without going too much into too nerdy, let's say, details. Well, artificial intelligence, needs a lot of data. A lot, how much? Well, it depends on the application. We will see later how much samples, for example, we need in the case of ladle furnace, when we would like to create a model that describes the chemical physical behavior of the ladle furnace. So we start from collecting the data. We have example, input example, and the answer. For example, if our application is to forecast the final steel temperature at the end of the ladle furnace or before the continuous casting, well, the answer is the measurement, the historical, let's say, data related to the measurements of the steel temperature. And what are the examples? So the input data are, for example, the amount of energy we used, the mass of the steel, the types of the steel, the particular composition. If you have more carbon, less carbon, let's say the heating distribution will change in time, so the temperature will change. We split the data. We take a part of this big, let's say, collected set of data from historical data that we have in the plant. We take a part for using it for doing the training of the model, to make the model understand the physical behavior of the system, and then we use another part of the data set we collected to test the model, to check if the model can understand data that during the training wasn't seen, wasn't checked, let's say. So we train a model. How we do it? Well, nowadays there are several tools to do it, and in the future we will have more and more advanced and simpler, easy to use tools to starting from data for cleaning the data to create such models also in industrial application. We train this model with specific tools, and then we evaluate the responses of the models. So the questions are these models accurate enough for our specific application? Do the results make sense? Or if the results make sense and there are some errors somewhere, for example, in the prediction of the final carbon content, in function of how much anthracite or I don't know carbon we added in the ladle furnace, no? How we can improve this model? What type of data we can give, additional data we can give to the model to make him better understand the physical behavior? Well, these are the questions that at the end you are going possibly to answer during the test of this artificial intelligence-based system, because we need to fully do a stress test to the artificial intelligence software to understand if this model is trustable or not. Maybe for you it's strange to be heard of by a scientist that works in this field, but we cannot trust artificial intelligence in the sense that before to use this application in real industrial field, well, we have to stress the tests a lot to understand if these are trustable, if the application of the results are dangerous for us, and so on. Pros and cons of artificial intelligence in our application. Well, several pros, because obviously can process a huge amounts of data very quickly. As human, we can reason in a very detailed way, and we are very able, and we will not be never replaced by such automatic software in the decision making. Why? Because machines can understand, let's say, some specific behavior, but in the details, well, the human beings are better and will be better. I hope we will be better also in the future, but as a scientist for now, I can say it very clearly. We will not be replaced by machines, fortunately. Well, machines, so this algorithm, this model can detect patterns that without sense we can miss because of some specific details, because of some particular combination of, for example, in our case of the chemistry that can change a little bit, and there are some effects in terms of final behavior of the steel or some specific mechanical characteristic of the steel and so on. Details that sometimes the human can miss, but machine can see. It's a support, so it's like the microscope. No, the microscope, we used the microscope to focus, to use our senses, to improve our senses. That's the idea. And obviously, another pro that this sentence is both in the pros and cons. Well, these methodologies, as it happens when we introduced the robots in the production, these require changes in how people works. Why? Well, as a pro, because it help us, so for example, avoiding some repetitive tasks. In cons, because in some specific tasks, for example, well, for me it's a pro, but if you think the people that work in the manufacturing chain, where the robots replace some specific works because they were very repetitive, because some works very let's say not good for the health of the operators, because they have to lift some too much weights and so on. Another pro, artificial intelligence can predict some problems or behavior before they happen. We also have disabilities, but not when we have to see a lot of data. Cons, well, sometimes artificial intelligence, the answers of artificial intelligence can be difficult to understand. How, I mean, understanding why a specific answer has been given by the model, no? And another problem, for example, is these tools works well when we have a lot of data and when the quality of data is sufficiently good, let's say, and the data is clean. As I said before, let's do not trust artificial intelligence models. Why? Because we have to test them. We have to understand if the answers, the results, the support that they give us is trustable or not. What kind of value can add to you in CELSA? Well, for example, can allow us to predict in our case, the final chemical composition at the end of the little furnace. This can help, for example, to understanding how much specific ferroalloys to add in advance. Instead of, we can reduce, for example, the number of chemical analysis that we do in the little furnace with less frequent sampling of the temperature, or I don't know, the chemical analysis. And that's already a good improvement in terms of improving the productivity, no? We can forecast in advance how the production will end, what kind of results we will have. We, for example, in our case, with 40 minutes before the end of the production of the steel in the little furnace. We can reduce the production of scrap if something went wrong during the production of the specific steel quality, reducing costs, materials, efforts, fatigue, and so on. You know, obviously, the idea is to support the operators. So these tools we are, let's say, suggesting to use in the next presentation I will show. These tools aims at help. Let's say the work of the operators, not to replace them or replace their experience. As I said before, as the microscope, it helps the operators, the chemical engineer or operator to check in detail, for example, the microscopy of the steel, the final steel microscopy of the final product, and so on, and can help us in enhancing our skill and supporting our work, or in particular on repetitive tasks. Final point of this presentation. Can artificial intelligence-based model be considered reliable? Well, what does it mean, reliability? From our point of view, as users of this system, or as workers, as also from the side of also from the company. What does it mean using artificial intelligence models in CELSA? Well, first point, trustworthy. Artificial intelligence methodology must behave, let's say, must be used with some confidence, because they demonstrate to be safe, because they demonstrate to respect, that their answer demonstrate to respect the people, the workers, they use such tools. Because for us, it's not enough that an artificial intelligence software works, but also it must behave in a fair and responsible manner. What does it mean, fair and responsible? Well, first point, reliability, obviously, because the model for us is reliable if the answers are, the answers are not absurd or produce some errors. I mean, if the answers are clearly false, for example. The model, the system, the software must be transparent. What does it mean? Well, we should understand how the model took some decisions, starting from the measured data. The model must be fair. in the sense that it must not discriminate personnel, the workers, in terms of penalizing someone because of his age, his gender, the origin, the geographical origins, and so on. Must be saved, but must be safe because the decision it takes must not cause harm to the people, to the process, to cause damage to the process. Must respect the model, must respect the privacy, the personal data, for example. Also, the data of the plant, the data of the specific company that use it, and accountability. And this is the most important point at the end. As I said before, we cannot trust this software. We must check if this software provide us good answer, good support. Why? Well, in the last years, in the last year, European community tried and is continuing to create some laws to, let's say, to understand who is accountable, for example, if a human or a company that use such tools, if something happens. For example, let's think we just bought our fantastic red new Tesla, and we switched on the automatic driver software, no? So we can stay relaxed in our car, see, the environment, see the trees and the beautiness outside the car. But what happens if the car crashes in a wall or in another car? Who is accountable for this? The company, also Tesla, that produced this, or who create the sensors? For example, the cameras, the video cameras that takes the images of the street and the lines and the signals and so on. Or we as our users are accountable of the fact that we pushed the button and the car did a mistake. So that's a huge problem not fully solved. But fortunately, at least in Europe, we have some real human intelligence. We are trying to create some laws that try to, let's say, to help us in using also some softwares. Final point, these software are decision support tools. So this software must not replace workers, but must, well, I don't like too much the term guide, but must give them support on the decision in specific situation, and must provide some corrective action, for example, to prevent some defects on the production. But these systems are not supposed to be used in closed loop, so in an automatic way. So the operator see the results, reason on the results, and understand if they can apply the final decision, let's say, that these specific software tools provide to the operators before to take the action. That's an important point. And that's the end of the first, let's say, the introduction of this. If you have